Welcome to myprojectbazaar.com. Now we are going to discuss about the project feature extraction and identification of Alzheimer diseases based on latent factor of multi-channel EEG. Now we are going to discuss about the abstract of the process. The processing and analysis of EEG within a proposed framework has been carried out with DWT, that is the discrete wavelet transform, for decomposition of the signal into one frequency subbands, and a set of statistical features was extracted from the subband 2 represents the distribution of wavelets coefficients. Then the reduction of the dimension of the data is done with the help of the PCA, that is the principal component analysis, and then the independent component analysis, that is the ICA. Then these features were used as an input of the neural network for classification of the data as the normal or otherwise it is an abnormal. So hence in this process we are using other than the neural networks like the KNN and the SVM. The performance of the classification was due to the different method is presented and then compared to the show the excellence of classification process. Hence in this process we have considered majorly the three kinds of steps, that means the feature extraction, classification as well as the optimization. So by using these three kinds of modules we can justify our process is efficient, because the reason is hence it is very stable and then it produces the reliable results. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this process. The process consists of the modules such as the input signal, pre-processing, feature extraction, feature matching, then performance estimation. Now this is the modules. Now the input signal is taken from the dataset. The dataset consists of both the signals like normal signal as well as the abnormal signal. After getting the any one signal from the dataset, we just move on to the next stage of the process, that is the pre-processing. In this pre-processing, the EEG signal will be converted into one subbands like alpha, beta, gamma, theta and delta. These are the subbands present in the EEG signal. After segregating the subbands from this signal, we just move on to the third stage of the project, that is the feature extraction. So in this feature extraction we can encode the features by using the three steps of algorithms named as ICA, PCA and DWT. DWT is nothing but the discrete wavelet transform. After the three steps we are extracting the features from the alpha signal, beta, gamma, theta and delta. After extracting these features we are combining to generate the test feature. After generating the test feature we have to give the two things as an input for the matching process, that is the train feature and then the labels. By using these two features we are going to apply the feature matching by using two algorithms named as the multi-SVM and KNN. Multi-SVM in the sense support vector machine and KNN in the sense K nearest neighbor. After performing these two classification, the output will be generated like the input as affected or non-affected, whether it is a normal or abnormal. After generating the results we just do the performance estimations. In this performance estimations we are doing the accuracy, sensitivity and specificity. By using these three parameters we can justify our process is efficient or not. Now we are going to discuss about the initial running procedure of the process. At first open the MATLAB 2015B and then change the current directory. If you want to execute the file, just right click in the main file _100.m and select the option run. After the selection of this button, one dataset will be open. You can select any signal from this dataset. After the selection of the signal you just click this button open. Now the selected signal will be processed one by one. Now I will explain the results one by one. This is the input EEG which I have taken from the dataset. Whether we don't know whether it is a normal or abnormal, so just we are taking the input signal from the dataset with the title of input signal. After that we are going to do the filtering. So in this filtering we are first applying the filtering. Now the figure 2 shows the filtered signal. This is the sample filtered signal. Now this is the values of that filtered signal. Then the signal will be decomposed into 5 category, that is the alpha, beta, theta, gamma and delta. Likewise, we have splitted the single EEG into multiple bands. After the segregation of this band, we are just showing the values of alpha, beta, gamma, theta and delta. Now these are the values which we have represented in these tables. You can see the difference between the alpha signal, beta signal, theta, delta signal. Now these are the values. After getting the values from like alpha, beta, theta and delta, we are just going to extract the values of ICA, then PCA. So this is the value of ICA, this is the value of PCA. Then finally wavelets, we are applying the wavelets, that is the DWT. After extracting this everything, we are going to generate the test feature by combining all the features together. So we are combining all the features together to generate the test feature. Then finally in the classification stage, we are going to classify whether the signal is normal or abnormal. So in this SVM classification, it is found as an abnormal signal. In this KNN classification, it is found as the normal signal. Thanks for watching this video.